So as you probably realized, pyradiomics requires your files to be in STK readable format, and one of those is called an nrrd file. And in this video, I'm going to show you how to convert to that. So all you have to do is go to this GitHub repository with the link in the description. You're going to clone this repository. So you could either download all these files and put them in the same directory, or do a git clone on it. And then once you've got that on your computer, you're going to have it all in this one directory. And I'm going to show you how to run this from the terminal, and then I'll also show you how you could run it just using the Python file. So what you're going to need for this is your patient DICOM images. So that could be CT, MR, PET, or whatever, in one directory. So you'll want for each patient that you're going to do this for a separate directory with all their images for the one series in. And then similarly, you can put their structures in another folder. The structures can also be in the same folder as the images, that's okay, but only for one patient. And then I specified this output directory, which is where I'm going to save my nrrd outputs to. Okay, so we've got the images I need in this images directory, structures I need, in my case, in the structures directory, and I'm going to save my output to this folder. It could be anywhere. I just did this as an example. So now what I can do is open the command line in this folder. And if you want to run the program just from the terminal, then what you need to do is call Python with this DICOM to nrrd.py file. And then there's some arguments you can specify so that it won't have to prompt you for anything. So this is convenient if you're, for instance, going to do this with a bunch of patients and want to make a script out of it. So there's these 4 arguments in my case. And the first one is called the image directory. That's where my images are saved. And I've got the structure directory, which is where my structures are saved. Again, if your structures are in the same folder, you don't need this argument. I specify my modality. I don't need to do it because it's CT, because that's the default, but you could also definitely need to specify this if it's MR or PET. And then my save directory is where I'm going to do it to this output folder. So if I copy this and I was to run this in my terminal window, press enter. Oh, sorry, I need to specify which version of Python I'm doing, so I'm going to activate my cloned environment, which is called main, and then I'm going to rerun that. And it's going to say the stuff I gave it. I'm going to get some warnings because for a couple of my contours, they're actually oblique to my planes. So it's okay if you've got contours that aren't on the same slices as the images, it'll interpolate, but if they're oblique, it's gonna be an approximation. It's not going to be perfect. So just a heads up. In most cases, though, your contour should be on the same plane as your images. Okay, so this worked. So you'll see in my output now, I've got my images as an nrrd file, and I've got my contours separately as their own nrrd files, which then I could call the pyradiomics extractor function on to get the radiomic features. It'll work. Okay, so another thing is if you just want to avoid the command line and incorporate this into your own Python program, then what you need to do is just call in this DICOM to nrrd.py file. There's this function called convert all DICOMs to nrrd. So you could just call this function with the image directory, the structure directory, modality, and save paths. So that's just the one if you want to save everything to one folder. If you want to save your structures to a separate folder than your images, the nrrd outputs, then make this save paths parameter a list with the 2 different paths. All right, that's it for this video. Hopefully that solves your problem. All right, bye.